So hello, welcome everybody to today's webinar on stopping ransomware using artificial intelligence. Thank you for joining us. And we're here to discuss a number of topics related to privacy, AI, and data protection together with Hub Security's very own Chief Revenue Officer, David Hochhauser, alongside Dr. Celeste Fralick, Chief Data Scientist and Senior Principal Engineer at McAfee. Thank you both for being here today. We'll start our webinar with a brief introduction from David on today's discussion topics, and then Dr. Fralick will get the chance to introduce herself and begin her presentation for today. Afterwards, we'll get into a bit of a deeper discussion on everything related to ransomware security, including its ongoing threats and solutions. As usual, we'll leave some time at the end of our discussion for a short Q&A. So if you have questions throughout the presentation or throughout the discussion, you can just drop them in the Q&A section and we'll get to them at the end of the discussion. So now we'll begin with a few words from David before we hand off the mic for introductions.
Okay, thank you, Sterny. So as you said, I'm Dave Hochhauser. I'm Chief Revenue Officer for Hub Security. And my company designs and builds extremely secure hardware and software computing platform that we center around something we call confidential computing. So welcome to what I think will be a fascinating talk by Celeste. Let me just take a minute to explain why we're holding this session. And truth is, it really doesn't take too much to see why ransomware is of interest. So there's a ton of activity around it. It's constantly, headline news. It's causing tons of damage to business customers. You see news shutting down infrastructure, government systems, hospitals. Personally, I can't really use the adjectives to describe publicly what comes to mind when I think about people attacking hospitals, especially during COVID. But it does emphasize the need for creative solutions. So I met Celeste. I found that McAfee was really working on AI for ransomware, and I thought it would be fascinating and an excellent topic to hear from her. So also keep in mind, while the focus, obviously, we focus on educational webinars, it does relate to Hub Security's emphasis on securing and protecting AI. And I'll touch upon that briefly as time permits, if time permits towards the end of it. We'll be happy to answer any questions. Type in your questions and we'll answer them after the initial presentation by Celeste. So sit back, enjoy as the Chief Data Scientist for McAfee presents her views on ransomware protection. So back to you, Sterny, and I assume you'll hand it off to Celeste.
Yeah, thanks, David, for a great introduction. Celeste, why don't you give us just a brief background on yourself, just so our audience gets familiar with who you are and we can establish credibility.
Sure. Celeste Fralick, I'm the Chief Data Scientist and Senior Principal Engineer at McAfee. I am a retiree of Intel who purchased McAfee back in, I think it was 2014. And they asked me to stick around and run the AI group. And so I've done that. And when we spun out in April of 2017, I just stayed with them. I'm out of Lubbock, Texas, home of Buddy Holly, who inspired the Beatles, and home of Texas Tech University and its medical school. We're a big oil and cotton producing West Texas, nice folks, out in the country place. So let's hope my network stays up. And I've been doing this about 41 years now, and data science since day one. I'm a statistician, but a biomedical engineer by official degree. And I am not a security expert, but hopefully I can give you a few nuggets about stopping ransomware with AI.
Yeah, I'm sure you can. So why don't you take it away?
Sure.
All ears.
Okay, I did want to mention I'm a stage 4 breast cancer patient, and because of my, I'm in remission, but unfortunately, I take chemo every 3 weeks, which has destroyed my memory. So I will be using some notes, which is very unusual for me in my past life, pre-cancer 6 years ago. But so forgive me if I have to check on them. I just have chemo brain real bad. So anyway, let's get started. This is the agenda. Let's go through some fun facts about ransomware, AI, pyramid of complexity and intelligence, some review of malware types, detecting ransomware using AI. I'll give you an example that I have a patent on, and protecting against ransomware and building an AI ransomware detection model. Just some general tips if you plan on doing that yourself. As you can see, here's some interesting statistics. Andrew Ning, co-owner of Coursera and owner of Landing AI, he indicated that AI has, he equates it to the new electricity, and I can't agree more. It's something as now inherent in our lives, but as you know, with the cloud, with Moore's law, with internet, that's all great and wonderful, but unfortunately with the good comes the bad, and it has allowed adversaries to use it for ransomware, the most common type of malware. This particular slide, the one that surprised me most is the 26% increase of global GDP of AI by 2030. So it's going to be with us for a while. I wanted to share with you, making sure that we're all grounded in common AI terms, as both adversary and security companies utilize some form of machine learning, deep learning, or AI. Now, I start with the bottom of architecture and data management. Architecture is used for data lineage, and we want to ensure compute capability. Architecture is really the one of the Achilles heels of AI, because there's a lot of downsampling, there's a lot of filtering. It's one of the reasons only 47% of AI projects get into production. So data management, you've probably heard that. You're going to hear a lot more of it in the next few years, because people are finally understanding that data management is inclusive of data governance, quality, documentation, traceability, and other foundational items that are absolutely critical to data quality and a reliable AI product. I'm a big proponent of statistics, as you can imagine. All of ML, DL, and AI have some sort of statistics in them. It's important to understand the basics of statistics, particularly distributions, because in security, notably ransomware, it is nonlinear, and most models assume linearity. So you may be leaving accuracy on the table if you're using an inappropriate model for linear when your data is actually nonlinear. So ML, as you know, it trains and learns patterns. Deep learning is very complex, very layered. It's very difficult to explain how the machine came to that result. And so you'll see now the rise of explainability, which speaks to the strength and direction of the features that make up the result of deep learning. AI is the futurists believe that AI will finally reach the true AI of reason, logic, and value judgments by 2029. I'll be surprised at that. I think it'll be a tad later, but it is definitely a challenge when you see AI models using AI. Typically, it will use NLP and deep learning together. But marketing has come along and said, oh, let's throw everything into AI. So for ease of communication, what I'm going to do is just use the term AI throughout the entirety of the presentation. I'm a purist, so if I'm using machine learning, I'll say machine learning, if typically mathematically, but in this case, I'm just going to throw it all together and say AI, thanks to marketing. As you're aware, there are many types of malware, many which are listed here and some which are not, like fileless. That doesn't use files and it's stored in memory. Most of the types of malware tend to ebb and flow as policing actions converge on bad actors and shut them down, like Emotet was earlier this year, which targeted financial institutions. But there's also those type of malware like Mirai botnet that attacks IoT devices with weak passwords. And it has stayed around since 2016. And others utilize code from other malware. And as you'll see, it has become very big business for nation states and organized crime in ransomware. And many of these malwares that are listed here are used for implementing a ransomware payload. Let's make sure you know what ransomware is. Ransomware is malware that infiltrates computers, obviously, via phishing emails, typically, or other malware like Trojans. It holds data and system hostage. The ransom note will ask you for Bitcoin or like cryptocurrency to release a decryption key. Unfortunately, the longer you wait, the higher the ransom, and often they'll delete the files they'll delete more files the longer you wait. And they may or may not release the data and the systems. And once you get your system back with the encryption key, or the de-encryption key, I should say, you have no idea whether they've stolen your PII, whether they've stolen passwords, your critical financial records, and worse than that, you don't know if they have also put additional software on your system to attack your endpoint or your systems again in the future when you're not looking. So ransomware is pretty nasty. Cyber criminals continue to follow the money. Bitcoin, cryptocurrency go hand in hand. And one of the things I did want to mention, just checking my notes, is that once a bad actor has infiltrated your system, it can locate APIs on your APIs to call your backup copy. So it's sometimes people will say, oh, and I do it as well, go ahead and do a backup copy of your an isolated backup copy of your system, but the bad actors have gotten smart to that, and they found your API of that calls a backup copy and infects it prior to detonation of the ransomware. So it's pretty nasty, and cyber criminals continue to use cryptocurrency, and it's just skyrocketing. There's good and bad to cryptocurrency, but it certainly has escalated the use of ransomware. So just some fun facts about ransomware. It is the most prominent malware threat nowadays. So as you know, ransomware hits every 11 seconds, and the predictions show that ransomware will cost $265 billion by 2031 annually. It's currently at 20 billion. So that's a 1,000% growth rate in 10 years. So it's really kind of scary. Your average downtime after a ransomware attack is about 21 days. There is not really an average of how long ransomware stays in your system before the ransomware is detonated. It can be 1 month, it can be N months. The important part is ensuring that you stop their access with the other malware that is typically hiding the ransomware. Now, ransomware has, as a service, which is a custom created variant of a ransomware family at a low volume, is taking over. So the ransomware for unique families have gone down, but ransomware as a service has gone up, because what they do is they sell small bits of code to people for a part of the ransom or a small fee, and it has become a big business for organized crime in nation states. The ransomware dark side that attacked the United States Colonial Pipeline, resulting in a gas station shortage earlier this year in May. Access was gained through a closed VPN password account, and apparently that password was used in something else that was placed in the dark web, and the dark web grabbed a hold of it, stole it, and eventually used it against Colonial. This slide that you're seeing here is is from the McAfee quarterly threat report. This is the amount of new ransomwares. As you can see, in the first quarter of 2021, it's gone down, and that's based on what I said earlier, that the unique families are going down, but ransomware as a service is going up. So you can, the global threat report from McAfee, you can get that on our website, McAfee.com, every quarter, and you'll find that there's a significant uptick so far in general attack volume, increasing about 151% in the first 6 months of this year compared to last year. The FBI says that there's about 100 strains circulating around the world. I would guesstimate that is a small number. I bet that's more. And WebRoot analysts will look for polymorphisms in the ransomware, and what polymorphisms are, which are seen in 97% of general malware, is that it will create modified version of itself to avoid detection, and they use different encryption keys, making it very difficult to pin down. Now going the wrong way. Okay, so I'm sorry, I don't know how to get rid of this little thing up here so you can see the top, but I did want to point out the markets that are being hit by ransomware. Financial, energy, and media are about 14%, I believe, yes. And healthcare is 17%. They sell the records for about $408. It's the current going rate, and I just wanted to check. And with COVID, general malware attacks have also increased, as I mentioned, as more employees are working from home, and those employees don't have either VPN, router protection, or multi-factor authentication, which those three are critical when you're working from home. So, by the way, when I was checking my numbers and research on this, I did find that you'll see some different numbers about the markets from the ones that are listed here. But I think we can generally say healthcare and media and financial are always some of the highest and most lucrative targets. Now, this is a chart as well from the McAfee quarterly threat report. It's the top ransomware families. You'll see that our evil ransomware utilized a number of technical techniques. It is ransomware as a service. It targeted the Oracle WebLogic vulnerability, as did Sodekanobi, I think is the way you pronounce it. It does also utilize DLL sideloading. And on the left, you'll see that general malware stats, CoinMiner malware increased 117% due to growth in the 64-bit CoinMiner application, and Internet of Things surged 55% due to Mirai. Now, I mentioned Mirai before. It's been around for a long time, so a lot of these will ebb and flow, as I said, or it'll change some small part of code and reemerge as a new name. Now, Ransom EXX, they're in the light blue, has both Windows and Linux versions. It's delivered by it has Windows, and now it has Linux variants. It disables security products and loads a secondary payload into memory, so it's considered fileless, never touching the disk. It targeted the Texas Department of Transportation and some tech companies. CoinMiner, yeah, it increased 117%. I mentioned that. And now that you're starting to understand ransomware a little bit and know some fun facts, let's look at its life cycle. So that first thing underneath the tab there that I can't seem to get rid of, it says access. They first gain access via phishing, spam, vulnerabilities, passwords. Sometimes the victim doesn't have to do anything. You don't have to click on a spam or a spyware, or I'm sorry, an adware, or the victim doesn't have to do anything. It will take advantage of vulnerabilities like that Oracle WebLogic. Then they will execute credential theft without you knowing it. They'll sit in the LSA access, the memory dump. They'll use PowerShell, which is fileless. Then they'll laterally move. You'll want to make sure that any security product that you have does stop that lateral movement, because it's quite common. They'll perform reconnaissance on the best target in the organization. Then they'll go to the fourth point. They'll sit there and persist in the startup, the DLL, the file transfers, background ops, and then they'll take a look at your financial records, your insurance docs, and very often they will align their ransom note with how much insurance you have or how much money you have in the bank. And then finally, what the victim sees is the ransom note demanding that they pay cryptocurrency, which is typically hard to track, and you may get your data back, maybe. So again, remember that they may have an ability to sit in in your backup file as well. So as you can imagine, globally, ransomware continues to increase. Its volume noted here by the orange bars, and compared to, that's 2021 compared to 2020. Of the blue bars, you can see that ransomware is just taking off, and that's largely due to the ransomware as a service with lateral movement propagating the adversarial code. The reason they use RAS is because they can get more lucrative targets, they can get much more specificity, and like the Colonial Pipeline, they can wreak a lot more havoc. Like a human virus and a bacterial virus, they'll continually mutate and adapt to the host defense mechanisms. Vaccination helps with the human virus. Unfortunately, ransomware is more difficult because of polymorphisms that I mentioned earlier, country laws, and the many ways that they infiltrate computer systems, such as weak passwords and security vulnerabilities. And fortunately, security companies like McAfee have developed AI solutions that I've been a part of to defend against ransomware. And in the next slide, I'll show you an older patent method, which I helped to develop. And after that, we'll investigate ways that security customers and those embedding AI in their business functions and products can help protect against ransomware. This particular method that I utilized, or I created with my colleagues, started with, at any rate, first of all, we identified the file activity. Was it write to disk, new file, file write, and then we accessed the model. We used basic statistical properties, mathematical features of the file, such as Monte Carlo, arithmetic mean, entropy, and others. And we applied statistical-based thresholds, and then we compared the computed value against the expected value, because the difference determined the probability of the ransomware candidate or not. Now, a lot of folks will use those thresholds as, hey, 0 to 10 is benign. 10 to 50 is kind of a gray area, 50, and it goes on. Use statistics to determine what those numbers are instead of just using your thumb. And that's the one thing, if you don't take anything away, please use just basic statistics. This particular product that was utilized in our consumer product, the neural network wasn't hard. We did start with the lowest model, least complex model possible, and worked our way up. But the feature engineering itself, the first few versions had trouble scaling. But what if you're a data scientist? This is a product an AI approach that we no longer use, but because we've evolved from this. But what if you're building something for an internal business function, or you want to embed neural networks into a product to sell? How can you tell if the efficacy over a specified period that your customer expects? What is the reliability of your model? Do you know that? And how can you tell if malware has infiltrated your system that might harbor ransomware? How can you determine if adversarial machine learning attack, also known as model hacking, has occurred? So, what you see here is some of the answers to those questions are really critical to the integrity of the AI model that you're developing. So one of the most egregious issues that I find today is that 51% of companies do not monitor their model once it is in the field. And since all models decay at different rates, how do you know when your model begins to decay if you're not monitoring it? So the same goes for monitoring the development of AI models internally prior to releasing in the field. It's critical to monitor your AI performance to understand what may be causing the model to no longer perform against your chosen measurement. And I've chosen here accuracy as our performance measurement. You may want to choose say a false positive rate, or even a positive predictive value, whatever your business deems appropriate and valuable to the company and to the business. These root causes that are driving the decay over time are represented by consolidation from several sources in the rectangle, the colored rectangles there. They may be caused by malware that can harbor ransomware. So it's very important to understand why your AI model is decaying. I've not presented the math here. That's for another presentation. I'm writing a paper on it. However, once you begin to understand your aggregated root causes and decay rate, you can then calculate your mean time to decay. And you can share that mean time to decay, just like you can share mean time to failure on hardware. You can share that with your C-suite and your customers, the rest of industry. So let's go ahead and quickly look at one particular technique that bad actors use to infiltrate your system, called adversarial machine learning. Adversarial machine learning is where they can literally, without knowing, they use black box attacks without knowing your model, without understanding your features, knowing your features. They can use transfer learning to accelerate adversarial poisoning. So it's critical to monitor this very, very, very small FP increases, because what they'll do is, this is actually the chart, is one of my favorite charts from Papernaut in a paper of 2016. They will use a source machine learning technique like K-nearest neighbors to attack, say, a support vector machine with a success rate of 82%. And as you can see, some are less, some are more. But what will happen with these poisoning attacks is they'll slowly increase your false positive rate. And so what will happen is your SOC, your Security Operations Center, will look at it and go, oh, that's such a nuisance. It's a, it's a false, let's just go ahead and decrease or adjust the threshold so it stops alerting, or increase it actually. So unfortunately, that is one way that the bad actors know that they have corrupted your system. One experiment that we did had 700 features, and we just changed 10 of them using a white box attack. So we knew the model, we knew the features. We just changed 10 of those 700 features, and we were able to take the model and change the particular group of maliciously, they were malicious identified files, and they all turned into benign with just 10 of 700 features. So you can see that transfer learning can be quite naughty and used by the adversaries. Now, so I did mention the 51% of companies don't monitor models after deployment. You're going to see a lot of focus on that in the next few years. The other thing that I would recommend is how are you monitoring and alerting model performance in the field? So these are built upon another, they're not separate entities, but we take field information, feed it back into the model. We alert with statistically based thresholds. Can you predict that? And finally, you're monitoring concept drift, you're monitoring data decay, cyber security threats, your anomalies and volumes of your features in the model, your FP rates as at a minimum. Now, this kind of drills down a little bit more on drift, decay, cyber threats, anomalies, and models. You'll notice that the new threats, TP, TN, FP, and FN there, those are really very critical to understand whether an adversary has infiltrated your system or not. Finally, models must be trained, retrained. You should know what the rate is and why. This is the Achilles heel, main Achilles heel of AI, implementing a model and leaving it out in the field without maintenance or retraining. It's an invitation to bad actors. So be aware that not all monitors or alerts haven't been listed here, but at least it'll get you started down the right path. So in ransomware protection in particular, I would recommend that the MITRE ATT&CK framework will help you guide your approach and discovery, enforcement, and harden. Always update your endpoint protection and OSs, secure your Windows configuration. Yes, our app ransomware does impact Apple. So those, I didn't show the chart, but if you'll check our quarterly threat report, you'll see ransom or Apple malware is increasing at a very high rate as well. The file backups, you need to isolate them off the network, but understand the risk and include that risk within your risk assessment. Train your people, enable practices that are user transparent, such as encryption, firewalls, and analysis of emails. And if you're brave enough to create your own AI, these are just general pointers to target specific action in the ransomware lifecycle. Don't try and solve world hunger. Comprehend the nonlinearity and behavior of the outliers. Understand where they fit within the distribution. Consider that you're dealing with an infinite feature space and polymorphisms, and particularly in security and security malware, you're going to find, again, 97% of malware contains polymorphisms. That is going to challenge a data scientist's model and the data quality. Always start with that least complex model first, always, because of the compute footprint. The higher you go up that pyramid, the more, the larger the compute footprint. Utilize explainability, those statistical thresholds, and monitor. Lastly, if you see something unusual, question everything, like Uncle Al here, question absolutely everything. So we've reviewed the current stats of AI and ransomware, the pyramid of complexity and intelligence, ransomware lifecycle, the brief review of ransomware solution that I created, model decay, mean time to decay that you can calculate, adversarial machine learning or model hacking, a covert way of bad actors getting into your system, and general monitors to protect your system. And if you're brave enough, general pointers to detect your ransomware. So hopefully I've given you a few nuggets with a short time together. Apologize for the problems we had at the beginning, and you understand ransomware a bit better. Question everything, and if you need to get a hold of me, that's me. And thank you very much for listening.
Thank you so much, Dr. Fralick. This is a super fascinating presentation, and I think for anyone who just woke up and dug themselves out of a hole and asked, "What is ransomware?" This was a really great introduction to the topic. So thank you very much, and thank you for your time and
Sure.
for your vast insights. I had some questions I would like to ask both you and David, and I also would like to open up the floor to our audience to ask any questions if they would like. As a reminder, there is a Q&A section below, so you can just click that and submit your question there, and we will get to them very soon. First off, David, any thoughts, anything to add before I get into some questions?
Oh, no, first of all, that was excellent. I was really completely in listening mode, actually listening pretty intently, learned quite a bit.
Good.
So that was really good. I see there are some questions though that are coming in first, so let's handle those first.
Okay, well, I see one from Tim. Thank you very much for your comment about your memory. What's the best way to attach this global virus that has attached itself to enterprise software? I learned of it on 60 Minutes a few weeks ago. Oh, I missed that one. It sounds like the code written will be impossible to stop since it's been infiltrating all software. Oh, yes, I've heard of this. I don't know. I don't know offhand how our security experts are attacking this particular virus. I do know that one of the issues that I've seen with our enterprise customers, and you might be aware that McAfee divested our enterprise business a few weeks ago, but I was mostly enterprise focused, and so now I have a new job in consumer. But with enterprise software, one of the things that you'll always see is layers and layers and layers. And one of the problems I've seen with some of customers, enterprise customers, is they'll, for cost savings, they'll buy only this particular solution. When they have an escalation, what we find is that, hey, if you had also bought this, it would have protected you. One of the things that I can recommend at this point is every one of our enterprise products, and there's a number of them. I don't set the prices, I don't do the marketing, mind you, but every one of those products are evolving on a routine basis to protect and detect. And what I would recommend as an enterprise customer is to buy, I hate to say this because I'm not into marketing or sales, buy as much as you can. If I left McAfee, I tell you what I would do is I would buy everything possible just for my home network, including the router protection. So how do you get on the offensive and attack the hackers with very large hammers? Actually, adversarial machine learning was the first time in security research that we have been on the offensive. And as we publish papers, we have actually found that adversarial machine learning has been picked up, as you can expect, by bad actors. But I would say that the things that we utilize in defense can also be used for offense. I find that the adversarial machine learning that my team has been focused on for about five and a half years now, and leaders in the industry, has been really the first time in security research that we've been offensive, and we really need to do more. So I totally agree with that. Could you please talk a little bit more about the feature extraction stage for ransomware extraction? In particular, we utilized the statistical normal features that you find in a file. Those particular features, I would always start with unsupervised learning, just to understand why things are separating. I would then understand what is driving the separation and the distance from center to center, not necessarily the center to the outside of that particular cluster in an unsupervised cluster. But specifically, we looked at entropy, as I mentioned, Monte Carlo, pi. We looked at literally arithmetic mean of the files. So if you'll, and you can find the patent online, it has an entire list of what those features are. And I think I've got them listed as well in the speaker notes. And the speaker notes, because my memory is so crappy, are very, very thorough. So if you don't want to listen to my voice anymore, take a look at the speaker notes, and they have the list of all the features that we used, or you can check the patent. Do we have time for one more?
Yeah, we have plenty of time. I mean, I had
Sure.
some questions I wanted to shoot at you guys.
I thought we only had till the top of the hour, so okay.
I think we can stretch out at least another 15 minutes, if that's okay.
Awesome. Let's see.
I'll just go through the rest of the Q&A. Yeah.
Sure. Does one need? Then let me see if I can find those. Entropy, Monte Carlo pi error, serial correlation coefficient, arithmetic mean, and chi-square distribution. I have also found in security, which is the data is very similar to human data, the way it works together with merging features together. That's a critical point. But you'll find that basic statistics and understanding the distribution of your data first and understanding those outliers and why they're outliers is actually probably 80% of the problem. And in most security problems and AI models that I've seen. Does one need to update the training data set every time to prevent decaying of the model, or build a new model from scratch? Oh Lord, don't build a new model from scratch unless it is decayed. No, what you want to do is you want to find, understand what is, first of all, you let me see if I can go back to that particular. One of the things you want to do is, first of all, identify the model. And that's the first thing. And then you want to identify that the current accuracy and measure over time that accuracy. And you can choose accuracy, as I said, or you can choose false positives, or false positive rate, or whatever is important to your business on the left there. But get that black line first. And as you find that it is decreasing, that is typically, what is you'll have to understand what is your pain point from your customer and your business, that at that point you want to retrain. So typically, if my false positive rate has skyrocketed, I've got to understand what the root cause is and immediately retrain. I would rarely create a new model unless I want to evolve or jumpstart. For example, if you have a model that's an NLP model that is looking at languages, and you've got one for every language in the world, you can look at the model decay on every one of those languages for the rest of your life, but you're going to be inundated with model decay just because every model decays at their own rate, depending on the root cause. And so if I created a new model that was multilingual, that would be a jump in an evolution of my AI. So I would, it's a totally different model. That's when I would do a new training model. Sorry, a new model, not retraining, but a new, completely different model and a new approach. So I use one model for multilingual instead of hundreds, almost thousands of different language models. I noticed a confusion matrix in one of the slides. What kind of independent variables need to be introduced to not only detect the attack, but also hit back? I hate to say this because I did this when I was a regulatory and biomedical at Intel. It depends. Again, it depends on your model as to what dependent and independent variables you have to detect the attack. And again, I highly stress unsupervised learning to begin with, to then eventually drive to supervised learning. Unsupervised learning in the feature space can tell you so much about that, the behavior of the malware. What kind? again, I'm sorry, I wish I had something better than it depends. It really depends on what your output is and what you're looking for and what part of the life cycle in ransomware that you're targeting. I can guarantee you that every part of that life cycle, and that was a very general life cycle, it can be very detailed. Every part of that life cycle, the bad actors have utilized. So you'll want to either tackle, if you're creating the security product yourself, you'll want to understand the risks of and the probability of attack throughout that life cycle, and hit it really from a Pareto. 80% they're going to be attacking using this, 20% they're going to be attacking using the rest of them. So I would go after the big hitters first, understand it from an unsupervised learning standpoint, and understand your output and what's driving that output. And I understand independent variables, but again, it really depends on what you're looking at for the particular model. I didn't answer that very well. I'm going to have to noodle on that one a little bit because it's a really great question, but
that's all right.
I hate to give it depends.
Everybody has an email and they have some contact information for you. So if they'd like to reach out, and you can try to give more detailed response.
Yeah, it's I can tell you that most governments utilize a lot of the things they get hit with attacking. So hopefully are gone those times where people are killed and you're just waiting in line for gas. But unfortunately, things like healthcare, we have literally gone in from a nurse's station to a vital sign monitor rack, 5 or 6 vital sign monitors in ICU, and we can literally go in and break it and change those results, change them at the nurse's station. And so it can kill people. And so question everything. Again, Uncle Al was right. How will quantum encryption in the hands of bad actors impact attack landscape? Will a Geneva Convention for Cyberspace be required? That's an awesome question. We can have a Geneva Convention. Unfortunately, there will always be bad actors. The quantum encryption will be quantum compute will be very difficult for all models. All of the models, in my opinion, will have to be recreated to assume the 0 and 1 at the same time. So I know of a lot of larger companies that have bigger pockets in McAfee, like IBM and Microsoft have looked at quantum computing. I'm concerned about all of our systems and our models, no matter what they are, not just security. And we can have the Geneva Convention, but we will always have bad actors. We will have cyber war until we get much more offensive. And well, now we're getting into personal opinions. Yeah, I don't know.
Yes,
I'm more of a dove. I don't know. I just soon buy every product in the world for security, and hopefully that will protect my system. Sadly, what has happened is just in the past 24 hours, my phone, wherever it is, has been spoofed. And someone, a bad actor has taken my phone number and utilized it as a callback number. And so I've gotten calls from 93-year-olds in Florida saying, "You called me, honey, why did you call?" And I'm going, "I didn't call. An Autobot has got my number," and it's not a virus on my phone. It's actually a virus. It's actually the policy of the phone company. And until enough consumers complain about it, our government won't do anything about it.
Yeah, well, now the phone companies are getting hacked too. I don't know if you heard about the T-Mobile hack.
Yes. Yeah. Yes, I heard about that. I'm on Verizon. But yeah, spoofing is, I had a wonderful chat with this 93-year-old man.
From Florida, you said.
From Florida. Yeah, he was a musician. He was so happy to hear that I lived in Lubbock, Texas, and Buddy Holly was born and raised here, who inspired the Beatles. And he goes, "Oh yeah, honey, I know Buddy Holly." So he's going to have a birthday next week, and
oh, that's wonderful.
Yeah, it's kind of funny how spoofing. He said I made his day, and actually he made mine. So
yeah, these are some wonderful random encounters. Yeah. We wanted to wrap up soon, and we don't need to wrap up the second, but we wanted to slowly wrap up. And I had a final question or two here that I wanted to ask you and David before we end our event. So just Celeste, for you, one final question. You mentioned that Revel uses DLL sideloading. Maybe you can give a bit more information to our audience on what exactly that is.
Sure. I'm not a software expert either, but I'm sure there are more experts on the call than I. But a DLL sideloading is when a bad actor takes a malicious DLL file and puts it in the same directory as a trusted exe file. And so when if the exe file tries to load a system DLL, it'll automatically go for the malicious one because it has the same name. And so the attacker doesn't even need to know when or what method the exe is calling in the DLL, because it's automatic and it's supposed to work that way. Unfortunately, the DLL has the same name, and it's done automatically. So DLL sideloading was used by REvil.
Thanks, Celeste. And a final question for you, David. Is there a concern about attacking the AI that protects us from ransomware? And if so, how do you think that we can protect it?
Okay, yeah, thanks, Sterny. And Celeste, first of all, this was great. And I don't mind having taken complete backseat on this because you know infinitely more about this than I do. So much rather be a listener on this. This is just, and I know you've talked a little bit about AI and some of the means to attack a little bit as well. And I just wanted to give you a perspective, my perspective on that, because we're in the cybersecurity business more than the AI business in one sense.
Sure.
And what we look to do is we see two avenues, really, as you mentioned, at a high level, right? The model and the data, two major places where you could start to attack. And what we see is that the security AI mechanisms, such as ransomware AI, are also one means of getting into that is, as you said, there's multiple ways to attack the model, multiple ways to affect the data.
Sure.
Gave a great example, even a simplified example, right? If an AI is monitoring cars for crashes, and somebody just changes the data to be 100 feet instead of 10 feet, or changes the model to say accelerate instead of stop, minor things can make a huge difference.
And we've actually done that experiment, and we can do it with AML.
Well, hopefully if you do it, don't do it with my car.
But we did it with a Tesla. We did it with an early version of Tesla. They have since corrected and patched that vulnerability.
Oh, that is good to know, because I know those things occurred. So that's, by the way, that's where my company Hub Security focuses as well. Is one of the areas we create an extremely secure computing platform, and the things that we do, we're actually looking to protect both any application, especially AI applications, and the data as well. We built the platform from a security perspective, and then built it up to include kind of the computing as well, the CPUs and GPUs that are running all of these applications. So we start actually from securing the environment. Our means is, how do we protect the model? We built these secure enclaves, where we use something called confidential computing. It's kind of the next security paradigm. And that's what we use. We run the applications and we put everything, the logs, the data, everything inside of these secure enclaves, the access policies, whatever it is, so no one can actually get to it, even while it's running. Actually, not even the company running it can actually get to it, that's actually accessing it. From the data perspective, we do the same thing, even protecting the data. One, we protect it at rest and in motion, which is pretty common. The other avenue is, again, protecting it while it's in use at the same time, so that no one can modify it. And we even permit things like, the more data you have, the better, but people are hesitant to share. So we could actually have multiple organizations share their information that's feeding into the model without anyone being able to see each other's information or the model, but they could share at least the insights. So it permits some avenue of at least collaborating on this respect. And around there's a host of other kinds of range of security controls around there. We have hardware firewalls that monitor every message coming in, every message going out. Even if the system's administrator's password was stolen, which is that's a pretty common way to get in, you still could not get into the actual application or the data to get to it. It would still prevent you from there. So as I said, there's a whole range of things around that platform, but our goal is to actually protect the AI models, especially even the security models, so that people can't, it severely limits them from attacking the model and attacking the AI to be able to get there. And I know we just started to talk with McAfee to see if there's some advantage of working together on that stuff too. But that's the essence of what we're trying to do to protect even the security mechanisms that are protecting us. It's a battle, building walls and walls around everything.
I'm familiar with this type of platform. And one of the things that I would recommend, if you haven't done it, is do a red-blue teaming and grab some security experts, if you haven't already, that are expert in red-blue teaming, and see if they can break it.
Yeah, we've done several times. We pay outsiders to break in, and we plan on doing it again in the near future. We don't trust ourselves doing that.
Yeah, no.
You have to have an outsider.
Yeah, it's definitely got to be black box.
Yeah, that's what we actually do have. We do have people outside who actually attack it, and we try. We're thinking of some other creative ideas how to do that as well.
I think that one of the protections, AML, while you don't see a lot yet, there was one particular study out of Australia that actually attacked 3 or 4 different companies, security companies, not McAfee, but they were able to use a black box not knowing the model, not knowing the features, AML attack, and they were able to penetrate the layers of protection of 3 or 4 different cybersecurity companies. In protecting, sorry?
I'm thinking about that. Maybe offline, you could actually send me the name of that company.
I wish I could remember.
Oh, okay.
I don't, but I bet if you Google, you know what? Let me find it, because now it's going to bug me if I don't know who that is.
Okay.
If I don't know the answer to something, I'm like a dog with a bone. Yeah, let me find out. It's been about 4 years, 3 years since that occurred, but they utilized black box AML attacks, and it was I don't remember whether it was a university or not, but I know they didn't attack McAfee, which was good for us at the time. But I know that if you can go on the offensive and put in measures within the layers of security to prevent AML, you can use things like noise, feature reduction, reinforcement learning. I believe what we have is a trade secret on it, not a patent. Because once you do a patent, then it's, obviously available to bad actors as well on the internet.
Someone's suggesting it in the chat. Maybe this is the right one.
Oh, let me see.
Well, we could take that off because it's getting late.
Yeah.
And we'll look through that offline, but I appreciate that. I actually just saved the link from there as well.
Yeah. Is it Australia? It was Australia, wasn't it?
Yeah.
Yeah. Okay. So my memory isn't that bad.
Not that, there you go. Not that bad yet.
And that's good.
Yeah.
Thank you so much.
It's going on forever trying to get on my side, so I'll stop that share there. So.
Okay. Well, thank you everyone for joining us today, and thank you to our speakers, David Hochhauser and Dr. Celeste Fralick. We hope you're all staying safe and healthy at home, and we look forward to hosting many more events like these. So don't forget to follow Hub Security on LinkedIn, on Twitter. Are we on Facebook? We're everywhere where you can find media and content, and to stay up to date and to get in touch. Sorry, with today's panelist, Dr. Fralick, feel free to reach out to them directly. All of today's attendees will be receiving an email in the coming days with their contact information. So don't be afraid to drop them a line if you had any other questions on today's really, really, really fascinating presentation. And yeah, don't forget to check out Hub Security's weekly digest on Medium, which covers the top stories, latest stories of the week, trending in the cyber and security sphere. Thank you once again, Dr. Fralick, and thank you once again, David. We hope to see you guys again. Thank you for having me. I really have enjoyed it and learning about Hub Security, and appreciate all the insightful questions. And please don't hesitate to email me if you have, if you want to carry on the conversation. And for all of those, please tell I always do this, but please tell your moms, your aunts, your sisters, please get a mammogram. It saved my life. I'm alive because of it for 6 years. So thank you very much, and stay healthy, be well. And I appreciate all of your time and your questions. Thank you for having me.
Thank you, Celeste. That was fantastic.
Take care.